Show how electron releasing substituents are ortho-para directing. Alright, so we have here a benzene ring. Attached to the benzene ring is a methyl. So methyl has a carbon and 3 hydrogens, and those atoms, they have electrons, and so the methyl is a relatively electron-rich species, so we can say that it's electron donating. Alright, our electrophile in the EAS reaction is NO2+. Of course, this is generated when you react nitric acid with sulfuric acid. Okay, so we are going to show how that substituent there directs that NO2 at the ortho position and at the para position. Alright, so let's do the ortho position. So we have CH3, yes. Alright, we have an H there and we have an H. It's not showing, but we do have an H at each of those carbons. So when the benzene ring attacks the NO2, and double bond O, of course you have a plus charge there. Alright, so that goes there. That bond attacks the plus charge on the nitrogen, and so you form this. CH3. So now you have an H there, and now you have an NO2 there. Yes? NO2, 3. We have a lone pair. That has to go there as a third lone pair. Right, we have a minus charge there, we have a plus charge there, we have an H there. Now we have a plus charge there. Alright, so let's show all of the resonance structures for that carbocation. So we have a plus charge at that carbon, so this bond here can help out, and you form this resonance structure. So that bond goes there. The plus charge goes away. It now moves from there to there. And you still have this. You still have the CH3. And you have the two H's, H and the NO2. You look at this. The N is positively charged. Yeah, so you have a plus charge on the N. You have an O minus there. Alright, the next resonance form is where that bond is going to go between that carbon and that carbon, so that the plus charge moves to that carbon. So the next resonance form would be this. That moves there. So now the plus charge is there at that carbon, which happens to bear the electron donating substituent. So you have a plus charge at that carbon, you have an electron donating substituent. So all those electrons are going to help stabilize that plus charge. Electrons, of course, are minus charges, yes? So the minus charges will help stabilize that plus charge, and that resonance form is favorable. That is why whenever you have an electron donating substituent, chances are an electrophile will add at the ortho position. Yes, because you produce a resonance form wherein the plus charge is at the carbon that bears the electron donating substituent. Okay? So H and NO2. This here is favorable. Therefore, addition is at the ortho position.